Good evening students. Today I am going to explain you electromagnetism. So electromagnetism, the name itself says electricity and magnetism both are interrelated to each other. So when you pass current, then in any wire, if you pass current, then around the wire there will be a magnetic field generation. It means whenever you pass electricity, definitely there will be magnetic field will be generated. This is nothing but electromagnetism. Electricity and magnetism both are interrelated. So here, if you take a bolt and if you turn a copper wire around the bolt, and if you pass current in this copper wire, then what happens is, whenever you pass current around the copper wire, there will be magnetic field generated. So magnetic field will be generated around the wire. This magnetic field will make the bolt to behave as a strong magnet. So when current is passed through a iron, magnetic field will be produced around it, and this magnetic field will make the iron to behave as a magnet. This is called as electromagnet. This is nothing but a electromagnet, and based on this magnetism and the electromagnet concept, we have in our real life electromagnetic cranes. Electromagnetic cranes are those which lifts heavy weights from the ground, and in order to lift heavy weights from the ground, we will use electromagnetic cranes. For example, in order to lift any cars which are fell in the valleys, in any accidents, if there are any cars fell in the valleys, then in order to lift such heavy weight cars or lorries or anything, we need a electromagnetic crane. They will lift all those cranes from the valleys and they will keep them on the ground. So in order to explain you practically, I made a small working model of a electromagnetic crane. This is a electromagnetic crane, and this is crane's hook. This is a crane's hook which is used to lift weights, and this is a bulb, and to this crane's hook there is a copper wire wounded around the crane's hook, and when you pass current in this copper wire, then around this copper wire magnetic field will be generated, and this magnetic field will make this iron that is this hook to behave as a strong magnet. Now let us switch on this electromagnetic crane. So this is a crane's hook, and to this crane's hook, this is a copper wire which is wound around the crane hook, and whenever you pass current through this copper wire, around this copper wire magnetic field will be generated, which makes this hook to behave as a strong magnet. And now when you keep these pins, this crane hook will attract the pins because of magnet, and it will lift these pins. So here you can observe hook is lifting the pins. You can observe the pins lifting off, and if you stop the current, if you switch off this, if you stop the current, again it will lose its magnetism because current is not passed through it. It will not lift the pins. Sorry. Yes. So now you can observe it is not lifting the pins. But when you switch on the current, so now I didn't switch on the current, so it is not lifting the pins here, but when I switch on the current, it will lift the pins. So here you can observe it is lifting the pins, whereas when you switch off, it will lose its magnetism. Now since there is no current passed, it will not lift the pins. So here you can observe it is not lifting the pins. Now how can you say how much weight it will lift? How can you say that how much weight it is going to lift? So it all depends on how much current you are passing through this, the coil. So in order to know how much weight it can lift, we need to know how much amount of current is passed through the coil. If you pass more amount of current, then it will lift more amount of weight. And second factor is number of turns. If you keep more number of turns, then it will lift more amount of weight. If you keep less number of turns, then it will lift less weight. So depending on amount of current passed and number of turns, so this crane can lift from the small pin to the heavy trucks and lorries. So it all depends on two factors. One is amount of current passed and second one is number of turns. So once again, for your purpose, I am showing a demo. So here, so now this is the switch to pass the current through the coil. So this switch is in off position. That is why this, since there is no passage of electricity, it is not lifting the pins. Since there is no current passed, it is not lifting the pins. Now I am switching on. Now it is going to lift the pins. So now pins are lifted. So since I kept the switch in on position, pins are lifted. Now I switched it off. Now pins will not be lifted. So now pins are not lifted. I hope the concept is clear. Thank you for watching the video. If you want still more interesting videos like this, please join my channel.